In my previous video, I discussed how to solve optimization problem using the 5-step method. At the beginning of the 5-step method, we made some assumptions. So our conclusions and our results all depend on the validity of these assumptions. In this section, under sensitivity analysis, we are going to talk about this. Again, in the 5-step approach, the process begins by making some assumptions about the problem. In practical situation, we know it is hard to expect all of these assumptions to be exactly valid. So, next thing to check is how sensitive our conclusions are to each of the assumptions we have made. As examples, what is the impact of the growth rate of pig? Last time we used 5, but you think it is constant always? In practically, I don't think so. And next assumption we did, price falling rate. What is the impact of price falling rate? We use 0.01. Price falling rate is not fixed number in practically. So let me explain using the pig problem how to apply this analysis. First, I will explain price falling rate. Let R be a rate at which the price is falling. Then the previous example in my previous video we use P equal 0.65 minus 0.01 T. But this case the 0.01 we use the R. So we use the R for the 0.01. Therefore, you can write down now P equal 0.65 minus RT. Then you can modify the equation y equal fx, previous equation 0.65 minus rx and 200 plus 5x minus 0.45x. So now you have equation with two variables r and x. So we get the derivative with respect to x of this function. Therefore find the derivative f prime x equal negative 225 rx plus 500 r minus 7 divided by 5. So as we did before, set f prime x equals 0 and solve for x. So you will get x equal 7 minus 500 r divided by 25 r. So you see the optimal time to sell is given by this equation as soon as x greater than 0. Therefore, you can get from above expression 7 minus 500 r greater than 0. So you can say 0 r 7 divided by 500, which is 0.014. Since the time to sell must be positive. When are greater than 0.014, the optimal time to sell is x equals 0. Please check the figure 1.4 in the textbook. Now consider impact of the growth rate. So impact of the growth rate G. So then we change the W. Last time we had the W equal 200 plus 5t, but we use G as the impact of the growth rate instead of 5. Therefore, this becomes W equal 200 plus GT. Now same thing we can do. Fx equal, write the equation 65 minus 0.01x time 200 plus gx minus 0.45x. Again take the derivative with respect to x. So then you will get 2gx plus 5 times 49 minus 13g divided by 100 equal 0. Then solve for x. You will get x is equal 5 times 13g minus 49 divided by 2g. So according to this, as long as g greater than 49.13, the optimal time is given by x. For this case, also see the figure 1.6 in the textbook. Now we can define a sensitivity function as the relative change in of one value causing the relative change in of another value. So I use the notation SXR. So this equal dx over dr time r over x. So in the big problem we use r equal 0.01 and x equal 8. You can remember these numbers. So then we can find the dx over dr. How do we find the dx over dr? Let me write down x. For the first case, x equal 700, 7 minus 500 r divided by 25r. So get, get the derivative with respect to r. From this case, you can write down dx over dr equal negative 7 divided by 25 r square. But we know the value of r, dx over dr when r equals 0.01. So just plug the 0.01. then you will get negative 2800. Therefore, we can write down the sensitivity, which is x comma r equal negative 2800 r divided by x, r equal 0.01, x equal 8. So answer is negative 7 over 2. So what is the meaning of this? This meaning, I can say, if r goes up by 2%, x will goes down by 7%. For the g, the same thing. So you can do this one for the g. So you can write down s x comma g sensitivity for the g d x over dg time g over x. So plug the values of g and x. So then you will get 3.0625. So this meaning, if 1% increase in the growth rate would cause to wait about 3% longer. So hopefully you understand how to work with the sensitivity. In my next video, I hope to explain some exercises from the textbook.